Welcome back everyone. In this lesson, we are going to be looking at setting up our input actions, okay? Setting up our input map, which is going to basically detect whenever we press a button on our keyboard or our controller or whatever sort of device you want to connect, what is that going to do? What action is it going to trigger? So to set this up, let's go over to the other folder. I'm going to right click, I'm going to go create, and right at the bottom, we have input actions, okay? I'm just going to call this one input actions right here. Doesn't really matter what you call it. And then what we can do is double click on it to open up. Now, this is going to open up the new input actions window right here. And there's a few things. First of all, over on the left-hand side, we have the action maps section right here. Now, action maps are basically like categories of controls, okay? They're basically control sets. Now, typically, you only really want to have one, so that's all we're going to create. So let's go ahead, click on the plus right here, and I'm going to call this one main. So this is our main action map that we're going to be using. In the middle is where we have our actions, okay? Now, with a new input system, it is made up by a collection of actions, okay? So an action will be something like move, jump, or attack, in our case. And each action can then have key bindings or buttons attached to it that trigger such action, okay? And those can be defined over here in the properties window. So for our first action, I'm going to double click to rename it, and this one is going to be the attack action, okay? So what button are we going to press to attack? Well, we can click on this little down arrow, and as you can see here, it's created a new child object, which is a binding. Now, a binding is a button or a controller press or whatever to basically call this action, to trigger this action. So if we go over to path, and as you can see here, there is a wide range of different controllers and input devices that we can choose from. We have gamepads, joysticks, keyboard, mouse, pen, even VR and XR controllers right here, which is very nice. All we're going to do is look for the space key, okay? The space bar is what we're going to be using to attack on keyboard. So there we go, space keyboard for attack. Now that's all good, but what about controllers, okay? Because we're using controllers as well. So how can we basically set up a key binding for controllers as well? Well, to set up multiple different devices, we can go over to where it says no control schemes, and we want to go add control scheme. Now, a control scheme is basically a way of inputting actions, okay? Are you basically inputting actions through a keyboard and mouse? Are you doing it for a controller? Are you doing it through a joystick? So let's click on add control scheme right here. And the first one is going to be our keyboard, okay? And we then want to go over to where we see list is empty. And this is where we are going to list all of the input devices that fall under this control scheme. Okay, so click on the plus, and I'm going to click on keyboard. Now, that's all we need to do. For requirements, this is going to be optional because since we are, allowing controllers, players might not want to play on a keyboard. If they have, 4 controllers, let's give them the option to have 4 controllers, and one of them doesn't have to be on the keyboard. So, requirements optional right there. Hit save. And as you can see right now, space is a global control scheme. So basically, everybody, no matter what device, will be able to use the space bar. But we don't want that, okay? We only want keyboard players to be able to use that control scheme. So over here in properties, click on keyboard, okay? Now let's create our controller control scheme as well. Let's go keyboard, add control scheme, and this one is going to be called controller. Okay, now for the list right here, we can open that up, and let's go over to where we have Gamepad. Now, you might be tempted to go down, okay, PS4 controller or Xbox controller, but we don't want to do that. We just want to go to where we have Gamepad up here. Now, Unity has a sort of universal Gamepad input right here, which basically falls under every controller that you can feasibly get, okay? So it has sort of universal buttons for the left stick, the right stick, the D-pad, the triggers. But if you do want to be specific, for example, if you are using the PlayStation 4 controller's touch pad interface, then you might want to do that specifically. But since we're just, designing this for any sort of controller, we can just click on Gamepad right here. Let's make that optional, hit save. Now you see suddenly that option appeared under attack. It disappeared, and that is because we are currently in the controller control scheme here. We can switch between them just like so, and on controller we need to give an input for attack. So let's go over to this plus right here, and we're going to go add binding, And this binding, if we go to the path, we can then go over to Gamepad. We then want to go button west. Now, if you have a controller with you right now, if you look on the right-hand side, you have your A, X, Y, B, or your X, square, circle buttons if you're on a PlayStation controller. And you have the north button, the south button, the east button, and the west button, okay? Now, the west button is going to be the one on the far left, so X on an Xbox controller. And that is what we're going to do for attacking, okay? So, as you can see, it is enabled by controller by default since we are in that control scheme right now. Let's go ahead and also set up our jump button or our jump action. So I'm going to go create a new action right here. I'm going to call this one jump. Now for that binding, we're going to make this a gamepad, and that is going to be the south button, okay? So we go here, find where we have button south right here, and that is going to be the A button on an Xbox controller. Now let's switch over to our keyboard control scheme and assign the jump button as well. Now for the jump button on the keyboard, this is just going to be the up arrow. So we can just search here for up arrow like so, and there we go. Now, one more action we need is our movement. Now, the movement is going to be a bit different. And the reason why is because it's not going to be a single action for move left or move right. Rather, we are going to be using a 1D axis. So, let's click on the plus here for a new action. And I'm going to call this one move. Now, for move, we want to go down to the binding and actually delete that. So, right click and delete it. And instead, we're going to create a new binding. So, click on the little plus next to move here. And go add 1D axis composite. Okay, we can just call this 1D axis. That doesn't really matter what this is called. But you'll see here that we have a negative and a positive binding. Well, what this means is basically move is now a 1D axis. So it can be either -1 or 1. Okay, if we want to move left, we're going to be setting this value to be -1. But if we want to move right, we want to set this value to be +1, okay? And to do that, we can go down here. So negative, this is basically what we use to move left. So for this, we are just going to go path, and we're going to go left arrow, okay? And for moving right, this is going to be our right arrow. Okay, so we can press left and right on the keyboard, and that is going to basically change this move action's value from -1 if we're moving left, to +1 if we're moving right, and 0 if we're not pressing anything. And we can then use that value to determine our velocity for left and right. Alright, so let's switch over then to our control scheme here. And for move, what we're going to do is pretty much the same thing. Okay, click on the plus, 1D axis composite. For negative, this is going to be our left stick. Okay, so we'll go path, go over here to left stick, left. Okay, so if we hold our left stick towards the left, that's going to move us in the negative. And for the positive, that is going to be left stick right. Okay, so left and right. So we have all of our actions set up right now. Let's click on where we have save asset right here to save all changes. And let's just go over it again real quick. Okay, so over here we have our action maps. These are basically the overarching categories or containers of actions. So most games will only really have one action map, so that's all you'll ever need to create and just have all of your player actions listed down here in the actions window. And an action is pretty much like a trigger or an event that gets called when a certain binding is activated, okay? So down here for our controller, if we click on the button south, which is the A button on an Xbox controller, this jump action is going to be triggered. And we can then connect this to a script through a Unity event, so we can call a specific function when the jump action is triggered. And we can then do whatever code we want from there. Now down here with the move, this is a 1D axis. So this isn't just one button that is either being pressed or not, okay? It's not a digital pressed or not. Rather, it's a more analog value that changes, okay? So we're looking at a float value for this action. And when this action gets called in the script, we'll have a function that basically can then read the float value, okay? And that float value can be -1 to 1, -1 if we're moving left, +1 if we're moving right, and 0 if we are just, standing still. And we then have our control schemes right here for our controller and for our keyboard, okay? Because of course, if you're playing on the controller, you need to have different button inputs compared to if you're playing on the keyboard and mouse. So we've got everything set up right here. Again, save that asset as it doesn't save automatically unless you click on autosave right here. We can then exit out of this screen back into our game. And in the next lesson, we are going to be working on setting up our player and connecting these input actions. So thanks for watching, and I'll see you all in the next lesson. Welcome back, everyone. In this lesson, we are going to be working on our player object, okay, our player prefab that we can move around, jump, and attack. So to begin, let's go to our scene view. I'm going to zoom in here, and we are going to right click in the hierarchy, and we are going to create a brand new empty game object. I'm going to call this one player, and let's just set their position to be 0, 0, 0, so they're nice and centered on our screen right here. And we need to add a few components, okay? First of all, we need a component to basically give our player physics, okay? So I'm gonna go add component, and we're gonna add in a rigid body 2D right here. We then want to add in a capsule collider 2D to give our player some collision so that they don't just fall through the ground. And, next up, let's actually be able to see our player. So over in the sprites folder, let's open that up. Let's open up our player sprite sheet right here and drag in the player 0 sprite as a child of player. Okay, I'm going to rename this object to be sprite, and you'll see that, they're not being rendered, and that is because our sorting layer needs to be set to player. And there we go, we can now see our player. Now, with our player sprite, when they're going to be spawned in the world, what we're going to be doing is changing their color based on how many players are in the game. Okay, so the first player will be red, for example, second player will be green, third player will be blue, and then fourth player may be pink or something, okay? That is why our player is sort of black and white, so we can easily change the color and change the tint as we wish. All right, so let's go over to the player object right here. What we're going to do is change their tag, first of all, to player so that they are on the player tag. And this is going to be useful for when we are shooting and needing to actually detect, have we hit a player. Next, let's also add in a new layer right here. And I'm going to call this one player. Now, the reason why we have a player layer is because when we have multiple players, we want them to be able to go through each other. Go yes, change children like so. And the reason why we want them to go through each other is because if they're colliding and bumping into each other, it may be a bit annoying if you're trying to just walk around and you keep bumping into players. So being able to walk through them is going to be just fine. Now to make them actually walk through each other, we need to go up to Edit, Project Settings, and inside of Project Settings here, let's go over to Physics 2D. And down here, you'll see we have a sort of little matrix here of our layers. Now we want to look where the player at the horizontal and vertical axes align, okay, so right here, and disable that. So as you can see, player-player interactions will not be collided with each other, okay, so they'll just be able to walk right through each other. Exit out of that, and let's start working on our components. So first of all, our capsule collider looks pretty good. It matches the player pretty well, so we can just leave it as is. For our rigid body 2D component though, we need to modify a few things. First of all, let's go down to Constraints and click on Freeze Rotation on the Z-axis. This is going to prevent our player from rotating like this if they fall off a platform or land a bit weird. So we always want to keep our player upright. And apart from that, everything else can be set as is except for the gravity scale. I'm going to make that 1.5 because by default, gravity at just 1, seems a bit floaty. Okay, we want our players to be able to fall down pretty quick and then jump back up in the air. So we've got that all set up. Now, next up, we need to create an empty object as a child of player here. And this is going to be our muzzle, okay? This is going to be where our projectiles are being spawned from. So what we want to do with our muzzle is select it right here. And I'm going to set the position to be 0.36 on the X and -0.1 on the Y. So it's just in front of the player's weapon right here. So this is where we're going to be spawning our projectiles and then shooting them outwards like so. Alright, so that is our player object setup. Now we just need to attach a few more components. The first one is going to be a player input component, and this is a component that comes with the player input manager, or the new input system I mean. And in here is where we can define an action map for the player to be using. Okay, so I'm going to click on this little circle here, select the input actions action map, which we created in the previous lesson. It's now assigned right here. And then what we need to do is go down to where we have behavior. And we want to change that from send messages to invoke Unity events. And if we open up this events dropdown, open up main, you'll see we have an attack, a jump, and a move event. And what this means is that we can create a script which then listens to these events. So basically, whenever we press the attack, jump, or move button, those can each call their respective function in our script. And then we can move, attack, or jump when those are detected. So we've got all that set up. Now, what about the actual script that is going to be controlling the player? Well, for that, we can go over to our scripts folder and create a brand new C# script called player controller. Okay, and then we can go ahead, select our player once again, and attach this script just like so. Okay, so we've got that all set up. We've got our player right here. Now, finally, what we need to do is go to our prefabs folder and drag the player in to save him like so. And there we go. So now we have our player saved, and we are ready to begin scripting. But first of all, let's check to see if our colliders actually work. So in the game view, I'm going to press play, and we should see that our player falls to the ground and lands on the platform like so, which is good. Okay, if they do fall through, make sure to add a tile map collider to your actual tile map here, or make sure to adjust the player's collider. Now, you'll see that we're getting an error right here in the console. And the reason why is because when we created our background canvas, it also created an event system. Now, an event system is used to basically detect inputs from the UI's buttons and various other interactable elements. And on our event system component right here, you'll see we have the standard input module component. And this is basically got a big error telling us that this no longer works because we have a new input system added. Now, to fix this issue, just click replace with input system UI input module. That's going to update it to a more recent version, which interacts with the new input system. And there you go. Clear that console, press play again, and you should see no more errors. Okay, so we're good to go, and we are good to begin actually creating our player's code. So that's what we're going to do in the next lesson. We'll be setting it up so our player can move, jump, attack, and all that good stuff. So thanks for watching, and I'll see you all in the next lesson. Welcome back, everyone. In this lesson, we are going to begin scripting our player, okay, giving them movement, jumping, attacking, all that player logic that we need to set up for our game. So let's open up our player controller script right here inside of Visual Studio, and we can begin. Okay, so here we are. I'm going to go ahead and delete the start and update function since we don't need them just yet, and we have a blank class. So to begin, let's create our variables. Okay, now we're going to have a few variables. First of all, we need a public int for our current HP, so public int cur HP. This is going to be how much health we currently have. We then need one for our max HP, so when the player respawns, what is their HP going to be set to? We need a public int for their score, so whenever they kill another player, their score will go up. We then need a public float for the move speed, a public float for the jump force, and a public float for the max jumps, okay? Or a public int for the max jumps. Now, what max jumps basically means here is how many times can we jump without touching the ground? Because in many fighting games, you can either double or even triple jump in these sort of games. If you've played Super Smash Bros, you can jump quite a few times before touching the ground again. So that's what we're going to implement as well. And as well as max jumps, we also need to keep track of how many jumps we have available to us, okay? Because whenever we jump, we need a way of detecting, okay, the player's jumped, so they have 1 jump left, 0 jumps left, they can no longer jump anymore. So I'm going to create a private int called jumps available. All right, just like so. Now next up, we need to create a header here, and this is going to do with our components, okay? All of the components we need access to, such as a public rigid body 2D for our rigid body. I'm just going to call that ridge. We then need a public animator for our animator component, which we're going to be adding in a later lesson. I'm going to call that one anim. We need a public transform for our muzzle, and this is going to be where we spawn our projectiles from. Okay, now we have everything there set up pretty much. One more thing we need to do is add in another private float variable for our current movement input, okay? Now, current move input, this is basically going to store that float value from our move action, okay? -1 if we're moving left, 0 if we're standing still, and +1 if we're moving right, okay? So we can then use that value to move our rigid body around. So what we're going to do now is go down into the fixed update function, okay? Void fixed update. And fixed update is a built-in function to Unity which gets called every 0.02 times a second. It is basically similar to the update function, although it is being called a set number of times per frame. And the reason why is because when working with physics in Unity, it's generally good to have this at a fixed time step, just to allow for more predictability. So in fixed update, we're going to be calling all of our physics related things basically, okay? So first of all, we need to be moving around. So I'm going to create a new void move function right here, which we can then call in fixed update. So every frame, we're going to call the move function like so. And down here in move, what we're going to do is set our rigid body's velocity to basically move at whatever the current movement input is. So rig.velocity, which is a vector that is our movement and direction per second. So we're going to equals new vector 2. Now for the x, this is our left and right movement. So we want to have our current movement input and we want to multiply that by our move speed. Okay, so we can vary how fast we move. And for our vertical velocity, we are just going to keep this at whatever it is right now. So we can go rig.velocity.y. Okay, because if we're falling, we don't want to modify or mess with it right here. That will be over in like the jumping code, for example. Now, let's go and do the jump function now. So void jump right here. And this gets called, of course, whenever we press the jump button and we have the ability to jump, okay? If we press the jump button and we don't have any more jumps available, this isn't going to be called. But if it is called, then what we're going to do is, first of all, stop our vertical velocity, okay? So if we're falling, for example, we want to basically freeze our velocity mid-air and then jump on top of that. So I'm going to go rig.velocity equals new vector 2. Our x is going to be, whatever it is, since we can be moving and jumping. So rig.velocity.x, but our y is going to be 0. Then what we're going to do is add force upwards. So we're going to go rig.velocity, not rig.velocity, rig.add force. We want to add force upwards, so we can go vector 2.up, multiply that by our jump force, go comma, and then the second parameter is going to be a force mode 2D. And this basically defines how we want to add force. Do we want to add it gradually, like we're pushing a large object, or do we want to make an impulse, like we are hitting a baseball? Okay, we're going to go impulse since jumping should really be an instant momentum change. And that off with a semicolon, and that is our jump function done. So we've got these things here. Now what we need to do is basically connect these to our inputs. We've got our input map, we've got our input actions. How do we connect these to our script? Well, to do that, we need to go to the top here and add in the using Unity engine.input system library. So we can access that like so. Go down and we're going to create a few functions, okay? So in order to basically connect an input action to a function, we need to basically have a certain parameter, okay? And I'm going to do that just now. Let's go public void on move input. It doesn't really matter what you call the function. What matters is the parameter right here, which is going to be input action dot callback context, and I'm just going to call this one context. So this callback context basically contains all of the information that we possibly need to know about this input, okay? Is this the first frame it's been pressed? Is it being released? Is it being held down? What is the float value? What is the vector value, the int value, the bool value, etc.? All the information that we'll possibly need to know about this certain action gets given to us through this parameter. Let's create two more, one for the on jump inputs. Okay, so we got those three functions right there. Let's start with our onMove input function, okay? So basically, whenever this gets called, that means that we are pressing down one of the movement keys. So what we need to do is set our current movement input value. So we're gonna go car movement input equals context.readValue. Read value basically reads a certain value we wish. For that, we're gonna have float. And this is basically going to get the float value, which is going to be a range between -1 and 1, and assign that to our current movement input variable, which we then use in order to move our player left and right. Okay, pretty simple for that one. Now, when it comes to jumping, this is where we actually need to create a separate function to detect if we are grounded, okay? So in the onJump input, what we're going to do is check to see if this is the first frame that this button has been pressed down, okay? Because we don't want to jump every single frame that we are holding down this button, okay? So to check that, we can go if context.phase equals input action phase dot performed, okay? And this basically means the first frame that this input is pressed down. So if that's the case, we then need to see, okay, do we have any jumps available? So if jumps available is greater than 0, so if there are jumps we can do, then we are going to first of all subtract our jumps available by 1 and call the jump function, like so. Okay, and that is the onJump input function right there. So that is all we're going to do for this lesson. In the next lesson, we're going to set it up so that we can detect when we are touching the ground and then basically reset our jumps so that we can jump up and down, hit the ground, and perform how we wish. And then we're going to connect these functions to the player input component so we can actually see it in action. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to continue on with scripting our player controller right here. In the previous lessons, we set up our input functions, so for detecting when we have pressed the move input, the jump input, or the attack input. For the move input, we are basically setting our current movement input variable, which we are then using to basically move our player around here in the move function. And for the onJump input function, we're checking to see, okay, is this the first frame that this button has been pressed down? If so, do we have any jumps available? And if so, then call the jump function, which basically adds force to the player upwards. So to begin, we are going to be creating the onCollisionEnter 2D function. Okay, down here, void onCollisionEnter 2D. This basically gets called whenever we collide with another 2D collider. Okay, and it has a parameter of basically the collision information. So what we want to check to see is if we have collided with this object that is below us, okay? Because if we collide with an object with our head, for example, that doesn't mean we're standing on the ground. But if the object we are colliding with, if the collision point was below our waist, then, most of the time that means we are standing on the ground or standing on some solid surface. So to check that, we can go if collision.contacts. Contacts is basically all the contact points that this collider has connected with another. It's an array, so we're just going to get the first element by going 0.point.y. If the y position is less than our y position, then it's below us. So transform.position.y. And if that's the case, then what we're going to do is just go jumps available equals max jumps. All right, just like so. That's all we need to do in order to reset our jumps. So now that we have that set up, let's go ahead and actually connect up these two functions, and this one down here, to our actual player input component so we can start detecting these inputs when playing the game. All right, so save the script. Let's go back into the Unity editor right here. Let's select our player prefab, or not our player prefab, but our player game object in our scene. I'm going to go down to where we have the player input function, open up events, open up main, and I'm going to add a new listener to attack, jump, and move. Now, for this, we need to drag in our player object like so into the object field. And the function, we click on no function, we go over to where it has player controller on move input. So just select the relevant function for whatever event is being called, so on jump input. And finally, we have attack, so player controller on attack input. So now we have connected our actions here to their respective functions in our script. Now finally, let's just connect everything up to our player controller script right here, and we should actually be able to then move our player around. So first of all, let's just start by attaching our actual components. So for that, I'm going to drag in the rigid body here. I'm going to drag in our muzzle here for the muzzle. Animator, we can leave as is for now. Current health, I'm going to set that to 3 as well as 3 for the max. Score, we're going to set as 0. Move speed is going to be 4. jump force is going to be 10, and max jumps is, let's just say 2, okay? So we can jump twice in the air before needing to touch down again. Let's press play and see if it works. So here I am on controller, I'm moving left and right. I can press up arrow to jump, and I can jump twice before having to touch the ground again, okay? 1, 2, no more. When I touch the ground, I can then jump twice again, okay? Which is pretty cool. So we got this all working. Now, a few things with our play controller is, as you can see, if I try and sort of go onto the side of a platform here, let's try this out, you'll see I get stuck, okay? If I jump and I move into a platform, I'll get stuck, and I'm basically not able to move until I stop pressing the right arrow key to fall down again. Now, that may seem not like a big issue, but when you're playing a game where, you know, you're trying to dodge projectiles and get around players, getting stuck like this, it isn't that fun. So how do we fix this? Well, first of all, what is the reason why this is happening? Well, the reason why is because all rigid bodies and Unity physics components have a certain amount of friction, okay? And when two objects are colliding with each other, even if they're both vertical, there is still friction that is being applied that is preventing one from slipping away from the other. So what we need to do is create something known as a physics material, which we can apply to our player and our tile maps. So let's go over to the other folder. I'm going to right click, go create 2D, physics material 2D. I'm going to call this one our player. And you'll see here by default friction is 0.4. Now we're going to reset that and change it over to 0. So there is now 0 friction between the player and their environment. So I'm going to select the player here, go down to the rigid body 2D component, drag in that physics material to the property right here, and let's select our tile map and do the same thing for the tile map collider 2D. Okay, so now both these objects have 0 friction. So if we press play again and try and get stuck just like we done before, you'll see it doesn't work, okay? I'm trying to move into the platform, but I'm just slipping out of it, and we can then basically move fluidly through our level now, which is really nice, okay? So there we go, we've got our player controller moving. Now let's have a look at the minor things that we need to fix. First of all, our player isn't rotating whenever we move left, okay? They're facing the wrong direction. So how do we make our player flip their direction when we are moving left or moving right? Now to do this, what we're going to do is just go to our fixed update function here, and underneath what we're going to do is go if current move input doesn't equal 0. So if we are currently moving in either the left or right direction, then we want to change our scale. So I'm going to go transform.local scale equals new vector 3. Now the X value is going to be whether we're looking left or right. By default, our local scale is set to 1, 1, 1. Now if our X is 1, we're facing right, and if our X is -1, that means we are flipping the player horizontally, so we'll then be looking left. So if our current movement input is more than 0, set it to 1, but if it's less than 0, set it to -1. And for that, we can do a ternary operator right here by going cur move input is greater than 0, question mark. If so, make it 1, colon, which is sort of like or, we can make it -1. And for the Y, that's going to be 1, and for the Z, that's going to be 1 as well. So this line of code right here should be able to flip our sprite or our player object left and right, depending on if we are moving left or right. Now, the reason why we aren't flipping the sprite right here is because we also have our muzzle, which is attached to our player's face and direction, so it will be a bit more confusing and a bit more code to set that up. So just flipping over the scale is easy enough, okay? But if this was going to be a more complex player controller, you probably would want to flip the sprite individually and not the whole player object. Alright, so now that we have done that, in the next lesson, we are going to be looking at actually spawning in multiple players with multiple controller devices. Okay, pretty exciting stuff, so I'll see you all then.